There's some inherent challenges to just keep in mind when we're writing our automated tests in practice, right? Ultimately, it's really important to remember that tests are code too, right? Because tests are code, they can also have faults, right? So when you have a test failing, it's often the case that you need to consider whether or not the test itself has failed, not just the code under test. Right? And we've actually performed a big study of this recently, and we found that up to 26% of test failures are caused by defects in the tests themselves. And that can be really impactful in practice, that in a way that's unfortunate, because when your test fails, you want it to be finding a real fault. Additionally, as we mentioned earlier in terms of non-determinism, it's common for 10 to 15% of tests to execute in a non-deterministic way. Right? This is where you run the test on the same code multiple times and it'll pass and fail inconsistently. Right? And that is another unfortunate thing to keep in mind when we're thinking about the value of our tests. So ultimately, right, when we're thinking about whether or not to embark on a testing approach, we really need to think from our team's perspective, how much risk are we willing to incur? And how much are we willing to pay? How much effort are we willing to put into testing to validate our system to the level that matches the risk profile that we actually have? And this is a really important intellectual process that every team needs to go through in order to correctly and effectively determine how much testing they need in practice. In review, the testing process is all about enabling these 5 steps so we can quickly and reliably go through and validate the behavior of our software system. And when we talked about testability, we were talking about these 4 different properties, 4 different ways in which we can improve the structure of the code to enable these 5 steps to be accomplished more easily. So controllability is all about improving the reachability of the different parts of our code in practice for our tests. Controllability is also an important property for improving the triggerability of the faults within our system. Isolatability is also involved in triggering faults, so this is an important property here as well. Finally, observability is unsurprisingly involved in propagation and observation of faults. Right? So when we make our code more observable, we're able to find those faults and move them down to a part of our system. We're able to see what's happening. And automation is about all of these different steps. Right? So it's about improving all of the first 4 steps. Now we'll note that the 5th step isn't actually listed from this list of properties at all, because interpretation is all about going back to our specifications and reasoning about what's actually correct within our software system. Right? Because when we start actually creating tests and throwing strange inputs at functions, we'll realize that we haven't specified all of the behaviors in our system, and it's important to think really hard about what the right behavior actually is in practice, and to write it down so it's captured in our specs, so going forward we know how our system's actually going to behave when it's given these unusual inputs. And this is really what testability and testing itself is all about at its core.